Today I'm going to be going over Lab 16 with you guys, which is going to cover abstract classes. So let's go ahead and jump over to Zybooks and see what we're going to be doing today. We can see today's lab here in Zybooks. As always, instructions are linked up above at the top, and you will be needing to download the Java files and get them set up in an IDE to work on this lab. And of course, once you're finished, you can go ahead and upload your files back into Zybooks for grading. Let's go ahead and check out the instructions for today's lab. So today's lab is really going to focus on abstract classes and getting you guys familiar with inheritance. Abstract classes are really cool because they allow us to define key traits necessary for multiple subclasses, but unlike normal inheritance, abstract classes cannot be an object themselves. Go ahead and scroll here. We've got a good example of kind of how an abstract class could be set up. You can have abstract methods in it as well as just, public methods. Abstract classes act similarly to inheritance, but they're defined differently and can include methods labeled as abstract. If you think about this example that we were just looking at, there's a compute area method which has the word abstract before it, which is going to tell the system that when another class inherits from this shape class, that class will complete any method labeled as abstract in the shape class. This really allows us to define methods needed by any class that will inherit from this abstract class. So let's say, for example, we have three subclasses. We have a circle, a square, and a triangle. So if we think about how we could compute area for each of these, we know that they're going to have unique ways. So if we make an abstract compute area method, you then have to define each compute area method for each shape. Abstract classes are really here to build kind of a base outline for our class, which can include some code, but really it helps us kind of relate multiple classes together. Below, we've got an example of how to define an abstract class, so check that out. We're also going to be looking over interfaces today, which are similar to abstract classes but have a couple differences. The main difference is when we declare, we're going to say public interface versus telling it that it's an abstract class. We're also going to be using the implements when we implement it instead of the extends keyword. So I also recommend you guys check out this example here so you're really familiar on how to set up an interface and implement one. If you'd like to check out this resource we provided for you, I highly recommend it and can help kind of go into a bigger difference between abstract classes and interfaces. But for today's lab, you're going to be completing code for a shape abstract class and three subclasses. So we can see the UML diagram below, which gives us a good visual representation of the lab. So we've got our abstract class shape up here, and we've got circle, rectangle, and triangle, which are all going to extend this shape class. In part 1, you guys are going to be writing abstract methods for calculate area and calculate circumference. Both of these methods will take no parameters and should both return a double. And remember, since these methods are abstract, the other classes are going to define these methods for their specific class. For part 2, you're going to work on the circle class. So you guys will be writing a constructor as well as accessors and mutators. And don't forget, you need to write those abstract methods that we defined in our shape class. Just as a reminder, those methods are going to be our calculate area and calculate circumference methods. So for these methods, think about how you can use a formula to return the area of our circle as well as circumference. And then of course, make sure you run through the test class to make sure everything is kind of outputting correctly and you're getting the correct numbers. You guys are also then going to work on the rectangle class. So similar to the circle class, you're going to need to write a constructor for this class, work on those accessors and mutators, as well as the abstract methods. And I know for rectangles, they don't have a circumference, so instead we just want you guys to return the perimeter of a given rectangle object for this method. And then once again, make sure you're testing this method, then that you're getting the correct output and everything's working correctly. Finally, you guys are going to work on the triangle class. So similar to before, you're going to need to set up a constructor for this class. You're also going to need to set up your accessors and mutators, and you're also going to need to implement those abstract methods, so calculate area and calculate circumference. We're really limiting this to performing calculations on equilateral triangles, so where all sides are the same length. We've also already provided the formula for calculating area down below, so remember that's base times height divided by 2. And as before, we know that triangles don't necessarily have a circumference, so instead return the perimeter of the triangle. And then, of course, make sure you do another test before turning it in. So that's all I have for the introduction for you guys today. I will walk you guys through how to set up your abstract methods in the next video, so please check that out if you're having any trouble getting started on this lab.